Welcome to week 3. Last week we went over some of the principles of data entry, and you all tried your hand inputting microbial data sets you generated into Excel. This week we're going to talk a little bit about how to begin exploring freshly input data, or often referred to as raw data sets, kind of lists of your actual measurements that you haven't really done a whole lot with yet. We'll teach you how to do this both in Excel, which most of you will find familiar. You've used Excel in previous courses, as well as start to introduce you to R, which will likely be new and different for many of you. Before we get into the R usage in particular, I'd like to just encourage you all to keep an open mind. This is going to be a little bit different than some of the things you've been exposed to previously, almost a little computer codey. But keep in mind that the intent here is not for you to master it, but rather we just want you to have a first exposure. And we'll talk a little bit more later on about why it's useful to be exposed to R and some of these other kind of less intuitive methods. So here we have the data set that we'll be working with for the next few exercises. I know you guys generated a data set on your own last time, and we'll eventually get to that data set in class this week. But for now, I wanted to focus on just using this classic example data set from the 70s that has data on 10 different features or variables for 32 different cars. What I like about this data set is that it's relatively straightforward and easy to understand. There's no discipline-specific prior knowledge needed. You don't need to remember anything about cell biology from Bio100 or anything like that to follow along with what we're doing. We can just follow along with the numbers and the variables. Everyone should know that MPG, or miles per gallon, what that actually means. It's how many miles you get per gallon of gasoline. I will say, though, that this is not a perfect data set. We talked a little bit about some of the principles of spreadsheet entry, some of the best practices last time. Take a second and just kind of look at this data set. Do you notice anything problematic? Some things might jump out at you, some things might not. For example, there's a lot of abbreviations here. For example, horsepower isn't listed as horsepower, it's HP. Maybe if you looked at this and you didn't know what cars were, you might think, hey, why are they listing Hewlett-Packard or something like that? So again, this data set is not an example of a perfect data set or perfect data entry. There's lots of little problems here that we've talked to you about. And so maybe looking through and trying to identify all the problems or things that you would do differently after last week is a nice kind of thought exercise when you get a chance. Other things that are problems in here, there's spaces. We haven't talked about how to use R yet or other kind of command line implementations of things, but spaces inside of your cells are actually quite problematic. Other things we don't see in here, what are the units? What's the unit of horsepower? Number of horses? I actually don't know. Now, this could actually be an appropriate way to do this if you have something called metadata. Metadata is basically kind of a key to your data set. You keep it as a separate file. I've actually included an example of the metadata for this file here. Here you can see that MPG is miles per US gallon, SIL is number of cylinders, displacement is really has to do with engine size, but here it's cubic inches. So if we actually go and look at the accompanying files or metadata with this data set, we actually turn out to be well within some of our best practices for spreadsheet entry. And so this is kind of a nice way to keep the data set clean while still providing all the relevant information. All right, so here's a subset of the cars data set, just to give us something nice to work with. We've got the car names as observations or rows with different variables for each. And here we've got just two variables. We've got miles per gallon, and we've got the number of cylinders in the engine. Often the first thing you'll do with what we call kind of raw data is conduct some basic summary statistics. Here we're going to do it by hand. I think doing things by hand the very first time around with very simple examples helps you understand what they actually represent. So to start very simple, we're not going to worry about miles per gallon. We're just going to look at the number of cylinders here. So we're just going to focus on the number of cylinders across these different cars. probably the first summary statistic or way of describing your data set would be, hey, how many actual observations do I have? How many different cars did we look at? And so we would call this the count. And that's easy to remember because it's how many of these rows are there? And we just count them. There's 1, 2, 3, 4, 5, 6. So the count of our data set is 6. We might also be interested in the sum of our data set. So what is the total if you were to add up all of your observations? And so if you were to add up all these numbers, you would end up with 36. That doesn't actually seem that useful. Why would we care that there were 36 cylinders across the whole data set? Well, one way that actually could be useful is we can use it to calculate the average number of cylinders. So again, this is probably review for many of you, but the average, or mean, is really just the sum divided by the count, which would be a 36 divided by 6. And so we could say that the mean, the average number of cylinders across this data set for cars, is 6. If you were to pull a car by chance, you're probably going to be close to 6 cylinders. Other ways of describing this data set, we might think about the minimum. What's the very lowest number of cylinders in the data set? Well, it's 4 right here. So the minimum is 4. We could also think about the opposite, which is the max. What's the max value in this data set? Well, it's 8. And then what's the central number? So if we were to start from the bottom or the top, so up here, and count all the way down to here, what's the value at the very center of all of our numbers? What's the very center row's value if they're ordered? And we would call that the median. You can think about it kind of being like the middle. And the median value is 6 here. This is actually an even number data set, so our median would be right here, and we would just kind of look at both of those numbers. And so our median is 6. And so that's really our basic ways of describing this data set. What I want to do here now is represent that the mean or the average, which is something that we typically throughout introductory level biology classes seen taken at face value. Many of you took Bio100 here and you looked at leaf width, and many of you looked at whether just the mean width of leaves differed between low light and high light conditions. And what I want to emphasize here is that the mean or average of two data sets is really just a small part of the story for whether two groups are similar or different. There's a lot more that goes into it. And so let's go ahead and look at miles per gallon now. And so here's that same data set right here. And if we were to calculate the mean of this data set, the sum divided by the count, we would see that the mean miles per gallon is 19.7. Now I've got another fake data set over here where every single row is 19.7. If we were to calculate the mean of this, well, the average or mean is also going to be 19.7. Now, are these the same data sets? Are these different from one another? And so if you only look at the means and you never actually look at anything else involved in the data set, they are absolutely going to look similar to you. But if you actually look at the numbers, you'll see that, wow, all of these are 19.7. These guys here have a lot more variation in them. And so descriptive statistics can also help us to try to define those differences. Something that you're going to see a lot in the scientific literature is standard deviation. This is really just a fancy way of saying how much variation around the mean is there. On average, how different are the individual observations from this mean of 19.7? And so it's beyond the scope of this class to get into the nitty-gritty math of how to calculate standard deviation. But what I'll say is that the standard deviation, and we'll abbreviate it as standard dev here, for the data set on the left is 3.2. What that means is that 70% of all the observations are within 3.2 values of the mean. So you could represent this as saying 19.7 plus or minus 3.2. 70% of your data set falls within that. And that's really what standard deviation is used for. Now, if we were to look at the standard deviation over here, where all the numbers are the same, standard deviation is going to be 0. Because over 70, all 100% of these numbers are within 19.7 plus or minus 0, right? 19.7 plus or minus 0. And so this is a nice way of defining how much variation there is in your data. Are all the numbers really close together? Are they really far apart? These are really important things for statistics down the road. Okay, so let's say that you're not a huge fan of standard deviation, or just looking at numbers in general, and you need to visualize things. Well, box plots are a really great way of visualizing the distribution of data or variability in the data. And while we'll cover how to make them next week, I want to introduce them to you today. This simple plot here, it's basically just a box with some lines and some whiskers coming out of the top and bottom. Sometimes they're called box and whisker plots for that reason. They actually give us a ton of information. They pretty much rehash all of our descriptive statistics that we already went over. They give us the minimum value of the data set, this whisker down here at the bottom. See how it's somewhere around 10.5 or so? It actually represents this number right there. It also gives us the max value in the data set at the tip of the whisker. That actually corresponds to this 33.9 there. And then right smack dab in the center is our median value. So this is the value that's smack dab in the middle of this data set. Now you might be wondering, well, what's the deal with this box here? And this is where the box gets its box plot name. So the median is kind of the center or 50th percent data point going from the top to the bottom or bottom to the top. This box plot also shows you the 25th and 75th point, also known as the first and third quarter or quartile. So really what this line right here represents is the 25th percent point of the data. And so if we wanted to figure out how to figure out where that should be, well, this data set has 32 observations. If we divide that by 4, we're going to get in between 7 and 8. So really, our 25th percentile or first quartile is going to be in between the 7th and 8th point. So we'd go 1, 2, 3, 4, 5, 6, 7, 8. And so 15.2. And sure enough, 15.2 is right there. Now we could do the same thing to get the third quartile or 75th percent point. We could go from the top and go 1, 2, 3, 4, 5, 6, 7. And so in between 7 and 8 is going to be somewhere around 23 or so. And if we look, sure enough, right around 23 is where our third quartile is. And so this is valuable because, look, we can, in just one easy plot, we can just see how much this data varies and where the center 50% of the data are between 25 and 75% of the total data set is, and then where kind of the outer 25 from both the top and the bottom are also occupying. And so this is really a nice, quick way to visualize your descriptive statistics. All right, so now that I've introduced kind of what are descriptive statistics and how do we use them, next I want to open up an actual Excel spreadsheet with these card data, and I want to show you how to calculate them yourselves. You don't always want to do things by hand. So the things that I'm going to want to touch on, and you're going to want to make sure to familiarize yourself with, and you can follow along in the video if you want, or you can pause it and kind of catch up and watch a little and pause it again, whatever works best for you. I want to make sure that we understand how to calculate count, sum, mean, median, and standard deviation. We're not going to worry about any graphing today. We're not going to make box plots or histograms. We'll worry about that next week. But I want you to be able to do these calculations on data sets on your own.